So the first thing about C, which is like really difficult to understand, is basically the pointers. And that's really how C differs from other languages that you've seen, is that C has sort of this notion of explicitly managing your memory and explicitly having like raw pointers floating around. So the cheat sheet on pointers is this. You have two opposite operators, right? You have this dereference operator, which is like, oh, what lives at that address? And you have the address of operator, which is saying like, oh, where does this live? Right? So if you think about this, if you apply the dereference and you apply the address of, they cancel each other out. Maybe that's like an intuitive thing, okay? So here's my question to you, because this is a common misconception we have. If I declare this pointer, int star p equals a hex deadbeef, right? Does star p equal deadbeef? Does p equal deadbeef? Or does address of p equal deadbeef? Address, P, what do we think? Who thinks star P? Who thinks P? Who thinks address of P? Okay, great, you guys didn't fall for it. So it is P equals OX deadbeef, right? So the idea here is now P points to that memory address, right? That doesn't mean that what's at that memory address is OX deadbeef, and it doesn't mean that the address of P is that, right? Does that all make sense? Okay, great. Next idea, you have this idea of C strings. And C strings are really just pointers to a bunch of characters in memory, right? There's not like an explicit string class like in other languages. So you have this C string, foo equals 61c f, and you have these addresses, and you have these bytes, right? So for example, this single byte is just one byte, and it's the C character, the S character, and so on and so forth. What's that character at the end? Null terminator. Right? So in every C string, it has to be null terminated. That's how you know how long it is. Okay? So even though this C string has length 5, it takes up 6 bytes in memory. Does that make sense to everyone? Great. So just quick questions. What is foo? Just yell it out if you know. Right, it's this hex. It's this hex address, like OX2A. Right? What's star foo? C. What's foo access 3? 1, 6, 1, right? Okay. What's star foo plus 3? 1. Right? So these two notations, we learned they're the same, right? Pointer math, basically this dereference operator, adding I, and then dereferencing that is just shorthands to that array access notation. Okay. The reason that this is true is you can think of like, oh, okay. Sorry. Here's my next question. Right. You see that this is a plus I elements. Right. There's like units here. So that's a plus I times the size of star a bytes. Right. So for example, here you have an integer pointer, and you have a pointing to this address. So you have a is this address, right? And a points to 14. Okay? And then you have a plus 2, right? That's 2 integers over. Okay? So that's, even though it's 2 integers over, the difference is 8 bytes. That makes sense to anyone? Okay. So, C structs, they're basically like bad versions of Java objects. You don't have methods, you can only have fields. You usually use C structs as pointers. Why? Yeah.
So you're not going to like recopy everything all the time?
Right. So the problem is you can pass C structs as parameters, and you can pass C structs, like you can return C structs from functions, you can set C structs equal to each other, and all of this will work as you expect. It's a copy, right? So the problem with that is then you're going to be copying a bunch of things, right? So think of it like this. Say someone has the wrong address for your house. Are you going to move your house over to the new address? No, you're going to give them the right address, right? So that's basically what this is doing. You have these pointers, and instead of changing what's at what that points to, you just change the pointer to the right place. Okay? So dereferencing struct pointers, because of this, it's really common. So you have this shorthand notation, which is the arrow notation, which is the same as a dereference and a member access. Any questions about that? Good. Memory management, I'm going to give you the rundown on this. There's not much to know. You have malloc, which takes in how many bytes you want to allocate, right? And what malloc does is, if it can find those bytes for you, it returns a pointer to that. If it can't find those bytes for you, it returns null, which tells you it couldn't find the right number of bytes. Free, it takes in a pointer which malloc returned and frees it, okay? That's like a really important concept. You can't just free anything. You can't free stack memory. You can't free the middle of a pointer. You can only free things which malloc had returned directly, right? So if you change a pointer to something, that's a memory leak, because then you can't free it later, because you've changed that pointer. You need to keep a copy of all the pointers you allocate through the program, right? And when I say exactly one malloc for one free, that means that every time you call malloc, there has to be a corresponding free call. No matter how the program executes, no matter how many times malloc gets called, there should be a free for it. Okay? What happens if I don't have a free call for a malloc? Memory leak, right? So potentially, I could keep allocating memory, and I could have these leaks, and then my program would eventually not be able to find enough memory. Okay? What happens if I free something twice? Undefined behavior, right? So it's undefined behavior. It's if you like try it on like modern compilers nowadays, it'll usually just crash the program. Okay. Yeah.
What does free return, and how do you check if it was successful?
Free is never not successful, I don't think. I don't think free returns anything. I believe it's a void type. Someone can check me on that. But yeah.
I'm still not sure what we like when we use malloc.
That's a great question. So the thing, I think I'll get into it a little bit later. But the reason you want to use malloc, you might say, okay, why not put everything on the stack, right? Stack is easy. Stack is like, you know, it's like the allocation is done for you. The problem with stack is that those frames are recycled, right? So once you leave that function, that memory is no longer valid. So you basically have to use malloc anytime you want to like return something from a function. If it's like I'm trying to think like a good example. Like if you want to return a string from a function, that has to be a malloc string. Because otherwise, once you leave that function, that memory might not be defined anymore. Okay. Yeah.
What happens if you define a string in the main? Is it put on the stack?
Yeah, it's on the stack. Well, depends on what type of string it is. We'll get to that later. But yeah, it's usually on the stack.
So why do you need to malloc it if you define it in the main?
Because with C, you can only malloc. Right. So like, what are you thinking? You're saying like, oh, I can have this character pointer, maybe to hello.
Yeah.
Okay, that works great if you know you already want to do hello. What if I take in user input, and then based on that I want to decide what I want the string to be, right? Then I can't do this.
Or like, let's say you're making like an object or something. Like,
Well, I don't have objects.
like a struct
See.
or something.
Okay, so you have a struct. Like what do you want to like do
Like
with it?
a node, like a struct.
Okay, a node struct, right? And like you want to make like new nodes.
Yeah. Well,
That's going to require you to did it really long, beautiful. That's going to require you to malloc space for the node, right? Because say you want like append nodes to it.
why can't I just put it on the stack? Like when I define it inside the main.
Oh, like you want to put all your nodes on the stack because you don't know how many of these node things you need, right? Like you can take in like maybe the user input says I want you to make 1,000 nodes. Are you gonna just put 1,000 nodes on the stack just in case you need them? You could, but I mean.
Or like when I define it in the main, where is it going? On the
It
stack?
goes on the stack, yeah. It does go on the stack.
But then you just said you don't want it to go on the stack.
You don't want to put it on the stack because first of all, your stack space is limited. You don't have infinite stack space in a program. You usually have around, I believe, 1,024 kilobytes. The next problem is that, say I said I want you to make 1,000 nodes, right? But you don't know how many nodes you want to make. The user says you need to make 1,000 nodes. How would you do that using this? Right? But with malloc, this is really easy, right? I can just mallocate space for 1,000. How many bytes do I need? Well, that's however much it takes to make one node. Right? And that would work with an ordinary malloc call. Yes?
Wouldn't the global variables be stored in static?
Yeah,
instead?
global variables are stored in static. This is actually in static, right?
Yeah,
This
so it's
thing
not
is
in
in
static,
static.
right?
Well, this S is in stack. This S is on the
yeah,
stack, but what S points to is in static. Okay. Okay. I don't know what we're gonna do now, but I think I'll keep going. So the next thing that you need to know is basically memory layout. Actually, let me see. Can everyone see? Not everyone can see if I do it here, right? Can anyone not see this? Okay. Alright, let's go. So Memory layout. What are the regions of memory? Code. Code, I heard stack. Heap. What else? Static. Beautiful. What goes in code? Code. Right? Does code go in code? Like if I write int main, does int main go in code?
It's the byte, it's the
like machine.
compiled
The
code.
machine code, the byte code, right? The result of like the assembling process you've learned goes into code. Great. Static. What goes into static?
Static variables.
Static variables. Good.
And then
Const.
variables.
So not const variables necessarily. Mostly variables which are declared globally. So globally declared. And then we did mention one other thing which goes into static.
String literals.
String literals. Beautiful. Do string literals always go into static?
No, they can go into the stack.
How can I make a string literal on the stack? Like I want to put hello world as a string literal. How do I put that on the stack?